Okay, this is class 9. This is going to be a relatively short lecture today because I want to give you time to start working on assignment 2, which is doing some DFAs, and I also want to give you some time to take that quiz. So we're not really going to cover any new material today. I'm just going to kind of explain assignment 2 a little bit and then give you time to work on that quiz. For the quiz, things you should study: Cartesian product, meaning the one set crossed with another set, producing pairs of items. The other thing that I want you to look at for the quiz is going to be graphs and the definitions of a walk versus a path versus a simple path versus a cycle versus a simple cycle. You should probably get familiar with those definitions before you take the quiz. And then one final thing, the difference between a function and a relation as represented by a set of pairs. So I would go ahead and, if I were you, take a look at those things and then take that quiz. Now let's go ahead and kind of move on to looking at assignment 2. So I'm going to switch over to assignment 2 here. Give me just a second. All right, so here's what assignment 2 looks like. And essentially what we're going to be doing is you're going to be drawing a DFA graph for each of the following languages. Notice that the alphabet here is only A and B. So those are the only characters we have to worry about in this. And the DFAs should accept any, all, and only those strings within the language. In other words, the language that's defined by the description, the DFA has to exactly match that and not have extra strings that don't match the description, not have some strings that match the description that are not in the language, and essentially make sure you get any possible string that matches that. And we'll talk about that a little more in a second. Now, one thing to do is make sure that your DFAs, that your transition function is a total function, meaning that every state and symbol, every state you have should have a transition leaving it, an edge leaving it, that basically has a label A and another one that's a label B. So every state has to have that. Now, if a DFA is not possible to construct, like if I give you a language where it's just impossible to create a DFA for it, then I want you to write it's not possible, but then give me a description or an explanation of why you couldn't construct it. What is it about that language that prevents it from being representable by a DFA? Now, looking at a couple of these here, you'll notice that going down the page, we basically have A through J, and then we have a bonus. And the bonus says all strings whose first two symbols match the last two symbols. So that would mean if you look at the beginning two symbols and you look at the ending two symbols, which can be the same symbols, like AA, that's the first two are AA, the last two are AA, that should be in the language. BB, same thing. AAA, the first two are AA, the last two are AA, that should be accepted. Now, let's actually do one of these together here so you can have an idea of how to go about these. So let's go ahead and do A here. So what I'm going to do is I'm going to switch over to the document camera. So give me just a second here. Okay, that's kind of weird. It like goes from digital world to real world of the same document. But let's look at A here. So looking at A, you'll notice that it's all strings ending in AA. So in other words, all strings entirely composed of A and B, but the end in AA. So here's how you would go about doing that. So in other words, if we were to look at a regular expression for this, but I'm not asking you to write a regular expression for this, but if we were to look at one, it'd be something like this: A or B star AA. So that's kind of the language that we're after. If it helps you to write down that regular expression, go ahead and do it. But what we're after here is a DFA. So, and we're going to draw the graph of it. You could write it out in the formal sense if you want, or you could just draw the graph. But anyway, it's going to have some starting state, which I'm going to label Q0. And remember, we identify a starting state like that. Now, one question we need to ask ourselves is the starting state a final state or not? And in this case, have we had an AA? We have not. We have not had an AA, so that's just going to be a single circle. Now, what happens when I get a single A? Well, I move to this state, which I'm going to call Q1. Is that a final state? Well, no, I still haven't had AA. And now over here, I get another A. Now I've had A followed by A. So now we're ready for a final state. I'm going to label that one Q2. So notice we had AA gets us to Q2. Now that, some people might naively think, okay, well, we're done. We have anything that has AA, it stops, but that we need all strings that end in AA. And notice this also has to be a total function, meaning that if I have this state Q0, it has to account for every possible symbol that we could get. So right now it accounts for an A going somewhere, but what about B? So the idea here is, well, let's use a B and loop it back into Q0. And so that's when I had an A. Now what about this? This doesn't have a transition labeled B leaving it, so we probably ought to add one for that. And the one we're going to add for that, we don't want to loop that back into itself because that would allow us to accept A, B, A. The two A's have to be together at the end. So if I get a B, I'm going to reset back to the beginning again. Now, once I'm in this final state, if I get more A's, I can stay here. So it would still end. I had an A, I get another one, it still ended with AA. If I have another one, it still ended in AA. But again, if I get a B, I have now no longer ended in AA. So I'm going to reset all the way back to the beginning here on a B. Now, let's see if this fits our criteria for what we were supposed to do. It has a set of states, Q0, Q1, Q2. It has a defined alphabet, A and B. It's got a transition function that's a total function because Q0 has an A transition leaving and has a B. 1 has an A leaving and a B. And 2 has an A leaving and a B. And we have a set of a defined start state. And we have a set of final states that's a subset of this, in this case, only Q2. So now this machine actually acts as a recognizer for this regular expression, or for this language that we were after, all strings ending in AA. And you can see that. So let's feed in a string. Let's say B, A, B, 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 A, A. Definitely got there. Let's say, what happens if we just get lambda? Doesn't accept it. What if I get A, A, B? Doesn't accept it. But A, A, B, A does accept it. So this machine now, in a very, I guess what I'd say, efficient way, we'll just chew through any string we feed it, and it'll say yes if it's in the language, or no if the string is not in the language. All right, so that's what you're going to need to do to these other ones. And let me switch back to the thing here. So all strings containing 3 consecutive A's means that somewhere in that string we had A together. They had to be together. But what comes before it could be any number of A's and B's. What comes after it could be A's and B's. As soon as I get A, I'll always accept. So think about how you'd make that. And I think these are kind of fun to do. They're like little logic problems to solve, kind of like a, how do I make this contraption that does what I want it to do? And one of the things that I like to do on that, let me switch back to this for just a second, is after I create what I think is right, take some sample strings and feed them in. Like, for example, AA, that definitely ends in AA. AA, yes, it accepts. B, 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 A, B, A, A. B, 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 A, B, A, A. Yes, that accepts. And try feeding in some that should be rejected too, like lambda. Yes, that rejected. What about just a single A? Yes, rejected. Single B, rejected. What about B, 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 A, A, B? B, 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 A, A, B. Rejects it. So make sure that it just kind of to check yourself before you wreck yourself. Make sure that you try some of these, some of them, and just as kind of a sanity check on that helps. Now, you can't check all of them, so you also kind of need an understanding of why it's doing what it's doing. So the set of strings containing the substring BAB, that's similar to this one, all containing 3 consecutive A's. This is kind of a substring AAA. This was having BAB. Now the complement of the language from C. Now what the complement is the opposite of. And there's one cool thing that I'm going to tell you here as a really massive hint. And that is, if you think about what one of these DFAs does, is it a string is in the language if it ends up in an accepting state, and it's not in the language if it ends up in a non-accepting state. So as a hint, if you can make the one for this, it's trivial to make the one for the complement of that language. And the way you do it is just take all of the accepting states. In other words, take your double circles, make them single, take your single circles, and make them double. And as long as your DFA is a total function, that will always end constructed properly for the language, this language. Then just by doing that one simple switch, you'll get the next one. And that's going to be something that's going to be important. We're going to come back to that concept later on. We can always make the complement of a language really trivially. And in some cases, you might think, well, I know how to make the opposite of this DFA, the language that's the complement of this language. If you can do that, you can make the other one. All strings with an even number of A's. As a reminder here, 0 is an even number. All strings whose fourth symbol from the left is an A. In other words, you count off 1 symbol, 2 symbols, 3 symbols, and then the fourth one. Is it an A or is it not? If it's an A, we accept everything after that. If it's not an A, it's a B, then we reject everything after that. All string whose every fourth symbol is an A, that would mean that you start off and you go, okay, 1, 2, 3, I got an A. Then you start counting over again. 1, 2, 3, got an A. 1, 2, 3, got an A. If you ever get a B in that position, everything should be rejected from that point out. If you get an A in that position, then you go accumulate more things. Now, one thing that's important to note on this one, though, this one can be a little bit confusing. So if I have, like, for example, the string, and let me actually just switch back over to the paper so I can write a little note for you here. All right, so let me scroll this up so you can see that one. So all strings whose every fourth symbol is an A. So A, B, B, A. That should accept because there's the fourth symbol. And also should accept would be A, B, B, A, B. That should accept because the fourth symbol is still an A. But this, A, B, B, A, B, 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 that one is correct, but this one is not. So this one will be accept, accept. That one would be reject. Okay, so just keep in mind that it doesn't matter if we add other symbols after that. It's just once we get a symbol in the fourth position, in other words, we will accept until we get a symbol in the fourth position that is not an A. So this should accept. And in fact, I'd argue that like that should accept because it has not had some fourth symbol that has failed. And this is why we have formal languages. Every string whose every fourth symbol is an A. Well, what if there is no fourth symbol? Is that accepted or rejected? And there's kind of two different machines that will come out if you assume that it's rejected. You'll get a different machine than if you assume it's accepted. And so I'll leave that up to you for your interpretation. But I would say that this, an A by itself, should accept even though it doesn't have a fourth symbol. And that actually is what I would go with for this. All right, let's finish up the looking at the rest of those, see if any other explanation is needed. All strings that start and end with the same symbol. That one's important to note that A, just the letter A, does start and end with the same symbol. I would also argue that lambda probably starts and ends with the same symbol because there are no symbols, but they're not different from each other. So I would argue here a lambda would be there, just an A would be there, just a B would be there, AA, BB, ABA, BAB. So in other words, if we look at the last symbol in the string and compare it to the first symbol in the string, then those two should always match. All strings that start and end with different symbols. So that would be the first one is an A, the last one is a B. All strings with no more than 3 consecutive A's. In other words, you want to allow it to have A's in the string and even groups of them, but you don't want to have more than 3 anywhere. If you get more than 3, then we reject it. If we have less than 3, we accept. So in other words, this is going to accept everything until I get 3 consecutive A's, and then it will reject everything after that. And then the bonus, which we talked about earlier. And remember, if any of these are impossible, then state that it's impossible, and then give me some sort of convincing justification. I don't need a formal proof, but I want some convincing explanation as to why it's impossible. Why could you not do this with one of these machines? Okay, so that's it for the lab. And so really quickly here, let's take a quick look at assignment 2 we already looked at. So now that's it. Again, take the quiz, study the Cartesian product, functions and relations, graphs, walks, paths, simple paths, cycles, simple cycles. Take a look at that and then take that quiz. And that's all we're going to do today. I'm going to give you time to work on that assignment because it's going to be important to have worked on that before we start classes next week. So work on that. Don't just squander the time. Take the quiz, work on the assignment, and stay safe, wash your hands, and I'll see you next time. See you soon. Oh, and if you have any questions on anything, shoot me an email, shoot me a text message, give me a call. As a reminder, if you do call me on the phone, send me a text message first so that I know, because spam calls come in all the time, and I'm not going to answer and listen about a car warranty being expired or anything stupid like that. So just send me a text message or give me a call and leave a voicemail, and I'll call you back as soon as I can. Also, email questions, Discord, however you want to get a hold of me works great. All right, that's it.